right, our last one that we're going to work, and this one is unique, has something really cool in it. So it's a little more different, but I'll get to it when we get to it. First off, I'm going to rewrite it, add my 0 there and my 0x squared so that I keep things the same. And I'm going to go ahead and factor it. This factors to x times x minus 1, and the bottom one was just x plus 1. There's not really anything to factor because there's no 0x squared. I just wrote that there so that we can find our horizontal asymptote in a little bit. Okay? Well, first off, let's go ahead and find our y-intercept. The y-intercept is those values, 0 over 1, meaning that it's going to be what? 0, 0. How do you forget the, how do you find the x-intercept? By setting the numerator equal to 0. So I have x equals 0 and x minus 1 equals 0. And once again, think about it. If the y-intercept was 0, 0, you know there's an x-intercept at 0, 0 and at, this particular case, 1, 0, because x minus 1 equals 0, so x equals 1. So I have two x-intercepts on this one. Ooh, two x-intercepts. All right. Next let's find the vertical asymptote by setting the denominator equal to 0, which means I have a vertical asymptote at x equals negative 1. Now let's find the horizontal asymptote. By the leading coefficients. Wait a minute. Whoa, Nelly, Coach Stoney. We can't do that. You can't divide by 0. So there is no horizontal asymptote. No horizontal. Whoa! How am I going to do this? Well, this one has something unique called a slant asymptote, and we find it by dividing. The original problem is this. So we're going to take this x plus 1 and divide it into this x squared minus x. Oh, Coach Stoney, remember that synthetic division problem that we worked last chapter? Where you wrote down the coefficients? Remember 1, negative 1, and 0? 1, negative 1, and 0, which I have right there. And this was the inside liar type thing. If it's x plus 1, I write negative 1 here. I make my mark right there. And the first thing you do in synthetic division is bring down the 1. I just bring it straight down. Now I multiply negative 1 times 1, which makes, whoops, this should be negative 1. There's an error. Negative 1, negative 1, negative 1 right there. That's a negative 1. And then we add it. What's negative 1 plus negative 1? Makes negative 2. Here I have it. I corrected it. Way to go. Got it corrected now. So I have negative 1 plus negative 1 is negative 2. Take negative 1 times negative 2 and you get positive 2. And add 0 and 2 and you get 2. So what does this factor to? If you divide this, you get, remember this is 1x minus 2, and you have a remainder of 2 over x plus 1. The slant asymptote occurs at y equals x minus 2. I get to ignore the remainder, but the slant asymptote occurs here at y equals x minus 2. I'm going to actually have to graph a line which will have a slant in it, hence the name slant asymptote. Slant asymptotes are lines. They're going to be line values. You actually could have some that are quadratics, cubics. You can have all sorts of different things in it, but we're only going to deal with slant ones, which are linear. All right? Thank you, Coach Stoney. All right, you're welcome. All right. So, how do I actually graph it? Well, first off, we do have intercepts at what? 0, 0 and 1, 0. It's kind of hard to tell the 0, 0. Notice there is a little bit. I kind of had to put that there. You can kind of see it back and forth. All right? There's a vertical asymptote at x equals negative 1. There is no horizontal one, but there is a slant one at y equals x minus 2. So I'm going to graph. Notice I'm down 2, up 1 over 1, up 1 over 1, all the way up and all the way down. So there's a slant asymptote. Ooh, this one's kind of nice. I know I'm going to go down like this here and curve back along this line, but I don't know whether the other one is like this or whether it's like that. How can I find out? Choose a point left of this vertical asymptote at negative 1. What would be the easiest value to choose smaller than negative 1? Negative 2. Plug it in, plug it in. So I'm going to plug negative 2 in. Negative 2 squared is 4. Negative minus negative 2 is plus 2. That's negative 2 plus 1 is negative 1. Actually, I have 6 over negative 1, which makes it negative 6. So at negative 1, I have a point at negative 6. Negative 6 is right there. So this one's going to slant in that curvy area there. Down like that. So your graph looks like that. Notice this one isn't horizontal. We still have these nice curvy lines. And there we go. That's what your graph will look like as we approach those asymptotes. The only difference, slant asymptotes occur when notice this was an x squared and this was an x. You will have slant asymptotes only when the degrees aren't the same and the degree in the numerator is larger than the degree in the denominator. That degree is 2, this degree is 1. It's not about the coefficients, it's about the degree. This is a 1 coefficient, and when I add the x squared, hence, this is the whole reason why I write these 0 x squareds on here, and these zeros to help me find like the y-intercepts and the horizontal asymptotes because of the leading coefficients. Some of the problems you need in this form to work and this form. As a review, you need the y-intercept and the horizontal asymptotes in this form. You need the x-intercepts and the vertical asymptotes in this form. All right? And if there is no horizontal, you will have a slant. Oh, wait a minute. So if there is a horizontal, can there be a slant? No. It's an if or. It's like you go to the store, you can, you have 25 cents, you can either buy bubble gum or, I don't know what you can buy for 25 cents, or we'll buy a pencil. You can either have bubble gum or a pencil, but you can't have both. You'll either have a horizontal or a slant, but you won't have both. And you can only have a slant if basically you don't have, like here, you have x squareds and there was an x. Only occurs when the degree is larger in the numerator. All right? So here's what you're going to do. What did we learn? We learned how to graph a rational function by finding the y-intercept, the x-intercept, the vertical asymptote, horizontal asymptote, poles, and slant asymptote. The y-intercept was found by looking at the last numbers, the constants. The x-intercept was found by setting the numerator equal to 0. The vertical by setting the denominator equal to 0. The horizontal is found by the leading coefficient. Poles are found by having common factors. And slants occur when you actually divide the problem and find out what that line is. The remainder part doesn't matter on the slant. All right? So, everybody at home, if you want to get a head start, it's page 157, 9 to 12, 19 to 26, and 43 to 46. I will see you on class Wednesday or Thursday, and look forward to it, and hope you had a good time. Thank you. You can go ahead. We can cut it now.
All right.